Hey guys, today we're going to be going over the 2022 AP BC Calculus answers this time, and let's get started into the video. Just a quick reminder that you can access these questions in the official PDF, which I have linked in the description box down below, or you can copy the link in the video shown right now and put it into your search bar. Just wanted to also mention that this is not affiliated with the AP College Board. This is just a video going over all the answers, which we'll do right now. First is question 4A. This is a non-calculator question just for reference. So there's this ice sculpture shaped like a cone, and it melts in a way where it is modeled by R, and it also gives us a table of R prime of t, which is centimeters per day that the cone melts, and t is in days. So now question A asks us to approximate f double prime of 8.5 using the average rate of change from 7 to 10. Luckily, 8.5 is right in between 7 and 10, which is awesome, and we can use the slope formula to find that value. So our t and r prime of t coordinate is going to be 7, negative 4.4, and our coordinates for 10 is going to be 10, negative 3.8. So using the slope formula, let's label our x1, y1, and x2, y2, and then let's plug it into the actual equation. So it's going to be y2 minus y1 over x2 minus x1. And since this is a non-calculator question, we can just leave the answer like this. Or we can actually solve it, which would be negative 3.8 plus 4.4. Let's see, 0.2, 0.6. Yeah, so our value for that is 0.6 divided by 10 minus 7, which is 3. And then you'll get like 0.2, 0.2 for that. Now for units, our 3.8 and 4.4 on the top were units in centimeters per day, and the 10 and 7 were in units of just day, so it would actually be centimeters per day divided by day, so it would be centimeters per day squared as your units. Now for the points, I'm thinking just a single point for the correct answer and then another point for the correct units. Okay, on to question 4b. We're asked if there's a time from 0 to 3 that r prime of t is equal to negative 6. Now, if you studied your proofs and your theorems, then you'll know that by the Intermediate Value Theorem, our first condition is that f must be continuous on the given interval. Well, this function is a twice differentiable function, and because it is differentiable, then it will be continuous by definition. And then it also must be in between two values of f of a and f of b, or in this case, it's going to be in between the values f of 0 to f of 3, and there will be an x value of c such that f of c is equal to k, which is any k value between f of 0 and f of 3. So let's go ahead and write that down, and our f of 0 is negative 6.1, and then our f of 3 value is negative 5, and then our c value must be in between negative 6.1 and negative 5. And so our c value, or our r prime of t, is negative 6, which is in between those values. So by the IVT, or Intermediate Value Theorem, there will be a c value between 0 and 3. For the points, I'm thinking just a single point for this question. It's kind of like you either get it or you don't. So that's pretty nice. And then now on to question 4c. We have to use a right Riemann sum with 4 subintervals to find the value from 0 to 12 of r prime of t. So let me just do a quick sketch of what the graph should look like. And this doesn't have to be accurate. I just do it just to like get an idea of what's going on. So whenever I have these like Riemann sum problems, I always make this weird looking graph. I don't know why, but it always helps. Maybe just because like it's a really nice pictorial way of viewing it. So here it is. I just have this sort of like x and y plane, and then I place my t values on the bottom, which in this case is 3, 7, 10, and 12, and then also 0. And then I draw this line on top of each one and place its corresponding y value or r prime of t value. For each number, I just place its y value like so. And then since we're doing a right Riemann sum, I just look at whatever value is to the right and the length of each interval to find my right Riemann sum. So my first interval is from 0 to 3, so that's 3 units. And then multiply that by the rightmost y value, which we're choosing between negative 6.1 and negative 5, and that's going to be negative 5 because it's to the right. Now I'm going to add that to my next interval, which is from 3 to 7, and that's 4 units, multiplied by the rightmost value, which is in between 3 and 7, and that's going to be negative 5 and negative 4.4. But the rightmost value here is going to be negative 4.4. And then just do the exact same thing for the next few ones. So from 7 to 10, that's 3 units, multiplied by negative 3.8. And then from 10 to 12, that's 2 units, multiplied by negative 3.5. And I like to use this method just because it's a nice depiction of what's going on and it won't really confuse you. At least I hope it doesn't. Okay, so now because this is a non-calculator question, we technically don't really have to solve it. But if you did, like if you happened to, have some extra time and you solved it, or you did, or you forgot, then it would be negative 51. And again, do not simplify this. This just wastes a ton of time. So just keep it unsimplified, and you should get all the points. Speaking of points, for the point breakdown, I think it's just going to be 2 points, one for getting the right answer, and then another for showing the correct work to get there. Now, for question 4D, we need to find the rate of change of the volume, and we have the equation given already. So this is actually going to be a related rates problem. Yay! So our equation is going to be the volume of the cone, and I'm just going to write that down off to the side. So we have the height, and it is decreasing at a rate of 2 centimeters. So this is not going to be our height, but it's going to be the rate of change of the height, so it must be dH dt. And that's going to be a negative 2 because it is decreasing. And we're also given the radius, which is 100 centimeters. That's r. And then our height, or h, is going to be 50 centimeters. And our dV dt, or the rate of change of the volume, is what we're trying to find. Now, before we solve anything, just note that in the problem it says that the cone is melting. If the cone is melting, that means our dV dt, or the rate of change of the volume, must be negative because the volume is decreasing. So when you're getting like a final answer, check to make sure that it definitely works, and I'll show you that later. So now let's find the derivative of v. To find dV dt, obviously. So if I take the derivative of v, remember that there are two variables, r and h. That means we must do a product rule, so do not forget that. So the derivative of v is going to be dV dt, and I just placed the 1/3 pi out and focused solely on the r squared and the h to do the product rule. And then it's going to be first, which is r squared, times derivative of the second, which is dH dt, plus the second times derivative of the first, which is 2r dr dt. And now let's place in everything. So our r value is going to be 100, dH dt is negative 2 centimeters per day, my h is 50 centimeters, my radius again is 100, and the dr dt, we're not given that, and so that might be a little bit of a problem, but we can find it by looking at the table which they gave us. And it says that we're looking at this at time 3 days. So at time 3 days, my r prime of t, or my derivative of r, is going to be negative 5. So in place of dr dt, it's just going to be negative 5. Now, you can honestly keep it unsimplified like this, but if you did want to simplify, it would be negative 70,000 divided by 3 pi. And again, note that dV dt is negative. And the units on this, it's already given, which is super nice. I don't have to find out my own. And this is going to be cubic centimeters per day as your final answer. Now, if you didn't look at the table to find your dr dt, you can always make a relationship between height and radius as well. So don't worry, you should pretty much get the same answer and get all the points for that. For the points, I think it's just going to be a point for the derivative of the equation symbolically. And then I think another point for finding out what dr dt is. And then another point for noticing that dH dt was negative 2 centimeters per day and not just 2 centimeters per day. And then the final point is for the correct answer, unsimplified or simplified. And then now here are my score predictions. These are my own, so this is what you might need to get at least a 3. And then my score predictions for a 4 or 5. Now remember that these are not the official scores that you need to get, but I've kind of formulated my own based on like past scores. And then also a quick update that the AP College Board is actually revealing some score distributions right now. They usually do so like 2 weeks prior to the score release date, which is July 5th this year. And so if you go on to Trevor Packer's Twitter, you can see all the percentages of who got what score. So far, they haven't released any calculus ones yet, but I think they should be doing it sometime this week. And then here are just some score stats for English Lit, which, by the way, is very impressive. Like, last year's 5 rate was 5%, and this year's is 16%, which is, like, so crazy. And so on the right as well, there are the A-push scores if you took that. And then he's posted a lot more tests, so be sure to check periodically throughout the day if you want to find out. And thank you for watching my video. Be sure to give this video a thumbs up, subscribe if you learned something new, and comment if you have any questions. Also, if you took the AP language test and want to know the answers, then check out the video to the left. And if you want to know the answers to FRQ number 3 for the BC Calculus test, then you can click on the video to the right. Thank you so much for watching. Be sure to stay tuned for my upcoming videos, and I hope you have a fabulous day.